Hello. So for today's question, so from practice questions, right? We have done all the arrays and hashing questions uh, from here. So what I'll do now, I'll go to the top interview 150 list in lead code, and I have selected this H index question because all the above questions I've already done. I'm trying to solve an unsolved question today. So that's what I'll be doing today. H index. I haven't solved this question. So we have an array of integers, citations. Okay, where citations of I is the number of citations a researcher received for their ith paper. Right. Okay, one second. I have to check the time. It's 11:45 right now. Okay. Uh, hmm. Okay. It's the number of citations a researcher received for their ith paper. Okay. So for their ith paper, they have received three citations. For the second paper, they have received zero citations. For the third paper, they have received 653 samples. Okay, fair enough. Return the researcher's H index. H index. According to definition of H index is defined as the maximum value of H. It's that the researcher has published at least H papers that have been cited at least H times. So we have five papers over here. Output is three. That means that the researchers is 5% total. Yeah, and they have received this many citations. Since the researchers has three papers with at least three citations each. Okay, three papers with at least three citations. Okay, three, five, and six. Okay, he has three papers. The remaining two with no more than three citations. Okay, H index is three. 131. So it has one paper with one at least one citation. It does not have two papers with at least two citations. That's why the output is one. Okay, fair enough. Let's go to the drawing board now. Try to ideate this problem. Mm, Right. This is a problem. So at least some citations with at least something. Okay. So we can check if one by one, maybe. We can check if we have one citation with at least one value here, right? Maybe start with zero because it's possible that we have zero, but then we can't actually select zero citations, right? We can start with zero citations, but we can't select. So check if we have at least one citation, at least uh, one research paper with at least one citation. So if we take this, we have this one, right? With one, we have this one paper with at least one citation, right? Then we'll check if we have at least two papers with at least two citations. This is paper, this is citations. So we have one and then we have three. So this is also correct. Then we can check if we have three papers with at least three citations. So we have, oh sorry, we don't have this available. We have one would not fit in this. We have, if we can do three or five and six, but one would not fit in this. Okay, fair enough. We can do three papers with three citations each. So we start with three, then we go to five, and then we go to 6, right? We have 3 papers, but we don't have any 4 papers with 4 citations. So we'll stop here. Now we have to go through the smallest number first, I think. So one feasible way to do this, I think, what if we sort the citations, right? What if I do this? Citations, sort them first. So that should be 0, 1, 3, 5, and 6, right? First, we'll check if you have one paper with at least one citation. Uh, 0 is not possible because it does not have at least one citation. 1 is possible. So, right, we pass this condition. So 2 papers with 2 citations. So 1 does not qualify here for that. 3 qualifies. So anyways, after 3, any number we have. So after 3, we have 3 papers, right? So we pass this condition. So we see if we have at least 3 papers with 3 citations. So we come to 3. This passes the 3 citations wala condition. And then after 3, we have 2 more papers. So counting, including 3, we have 3, 5, 6. So we also pass the 3 papers condition. So to have at least 4 citations, we have to come here, right? We can't select these 3. So we have 4 citations. We have a paper with 4 citations, but now we need 4 papers with at least 4 citations. So now, including 3, we only have 6 here. So we only have 2 papers. So this condition we fail. So we have to return this 3 as an answer for this. For 131, it would be after sorting 1, 1, and 3, right? So for paper and citations. So we have a paper. So we have one citation here, and we have one paper as well. This is one paper. So after one, we have, including one, we have 3 papers. So we have 3 papers of citation 1, which is more than 1 only. So this condition we pass. Uh, at least citation 2, we only have one paper. And after that, we don't have any paper. So we only have one paper with citation 2, which fails our condition. So this fails. So we have to return 1 here. We'll try to code this now. First, we'll sort the citations. So sorting the citations gives us O of n log n solution. It has not asked me to do it in O of n. So if n log n solution fails, we have to see if there is any viable O of n solution here. This solution is like very easy, I think. So maybe there's a twist in this question, but let's see. So, okay, how do I do this now? Okay, we'll set a pointer to the first element. We'll do this for I in the range. So we have 5 paper, right? So the maximum output we'll get is 5 only. So we'll do the range of 5 now. Okay. See. Okay. We have to store the answer as well. The rest should be 0 first. Then let's see. So for 1, right? For 1, I'll do C as I plus 1 because the loop starts with 0, right? This C should start with 1. So C would be I plus 1. So if C is 1, if C is 1, we have to go through, we have to reach the point in our array where we have value at least 1. So while citations of P, citations of P is less than equal to C. So this loop will stop when I'll reach the point, reach C for here. Okay. If, yeah, I just have to increase the pointer by 1. So now I have reached my, so my pointer now has reached a value where my pointer has reached the value where the citations and the number of citations required has matched uh, art, the research paper over here. I don't know why I'm having trouble speaking right now. Okay. Also, pointer should not exceed. The pointer should not exceed length of citations. Pointer should be less than length of moves. Okay. Right. Okay. P plus equals 1. Now, what I have to do? Hmm. So my pointer right now for I is equal to 1 will be would be here at P is equal to 1. Right. When P is less than nums. Now, if it's greater than equal to nums, then it should stop. Okay. So what I have to check now is that length of nums minus 1 minus P. So, so in for this condition I should be getting the value of 4. So length of nums minus P should be if length of nums minus P is greater than I, 4 is greater than I, then should continue this in the bracket. If it's less than equal to I, that means the condition should fail here. So I have to return I, so using C, right? And so what is C? I return C minus 1. Just like in this condition, 0, 1, 3, 5, 6, right? For if our C is 4, right? So then our pointer would be here. But then last element minus pointer would give us 2. 2 is less than 4, then should return 3 for me here. What if, okay, mm, what if I reach the end of the, I can do this also. Return C minus 1. if I reach the end of the array, so either ways, if I haven't written anything over here, right? And suppose the pointer is on the first, then it will return all the pointer minus, sorry, length of columns minus pointer. How much it will work? I'm feeling like a bit underconfident because I haven't solved this question. Okay, nouns we don't have, we have citations. I'm having trouble speaking today. Okay, wrong answer, but at least we got something. So, okay, let's try to debug this now. Print one, C, P, C, P. Oh, why do I have less than? Hmm, okay, that's an easy way then. I can do this if length of citations minus P, right? Is less than P, then I put rest as C, else, oops, break from the loop, return raise over here. Sorry. Okay. What the output is. And one and P and C as well. Pointer is on one, C is on right. We stopped. Oh, but did it stop? Not equal to instance. It's not going in the if loop. Then of citations minus pointer is citations minus pointer. If it's greater than equal to C, right? It's back. Yes. Okay. So this is working now. I'll put comments to explain the problem. So pointer is for checking the current paper with at least H citations. Okay. arrays would store the H index, right? So uh, C would range from 1 to length of 1 to length of how many papers the authors have. And then if the current paper has less citations than C, increment increment P by 1. Okay. Store the H index if it satisfies if we have at least C papers with C citations, right? Else get out of the loop and return the resulting H index. Okay. So I've added the comments to explain the code even more if it's not understandable. I hope it works after I submit it. Okay, we have gotten on this now. So we have, okay, let's do this. Let's take this to the sketchpad, try to visualize it. We have this. So if okay, wait, I can just print and I can just put the thing also. C is 1. I have to check here how much P. Okay, first I have to print the citations. How does it look after I've sorted it? So it gets easier for me to visualize where it's fitting. Then I'll print uh, how much the pointer goes ahead. So P current C, that's what I'll check. And then, okay, I'll do C first. I'll do P. And I'll also do citations of P. Um, okay, let me check. Me also. Okay, I can just copy this. And print 1, 2, 3 here. Print 4, 5, 6. So I know which print statement it's getting printed here. And then I'll print break here with the C and P values. Okay, let's see. Okay, so so this is a sorted citations array. Right. Our Earliest print CPM is also a strength up there. C citations of P. That's one. Right. So for one citation, this gets selected. Perfect. For one citation, we have raised one. For two citations, we have raised two over here. 0, 1, 2, 3, 4. So for P4, yeah, for P4, it should give me, so for P4, it should satisfy the situation. For C is 3 also, P4 satisfy this equation because we have 3 here. For C is 4, right? For C is 4, we require the, for C is 4, we require the 0, 1, 2, 3, 4, 5, 6. Yeah, sixth index, right? Sixth index, we have 4, 5, 6. So 4 is possible. For fifth, we require eighth. For fifth, we require eighth. So we have, what's the length? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15. So this is the eighth index, and we have 15. So 15 minus 8, 7. So this is again possible. Sixth index, sorry, for C is 6, will reach this index, which is ninth index, but then I don't see it going ahead after 9. Why is this range of 5? What the heck? It should be in the range of length of citations. My God. Okay. Silly mistakes like this waste my time. It's almost 30 minutes now, I think. I'm commenting the print statements, so it won't appear in the final answer. Yeah. Oof. It worked. uh, so this time complexity, it would be O of n log n because we are sorting the citations array here. Space complexity, it would be O of 1 only because we are not using another array over here to store the answer. We are just using a variable. So space complexity O of 1, time complexity O of n, O of n log n, right? And it's giving me 77%. So I think that's how I'm supposed to solve it. Yeah, people are sorting the array in the beginning. Yeah, so that was H index. It's 12:13 now. I think I started at 11:45, right? So it took me 30 minutes, almost 28 minutes. Medium question, 28 minutes. I think it's okay for now. But then I was having trouble speaking. So this I need to improve. This would improve over time, I think. I think this is my second unsolved question, right? The first unsolved question I did was yesterday, which was easy. This was medium. So yeah, but this was also a bit easier on the easier side. Just a silly mistake that I did that wasted my time. So yeah, That's the question for today and signing out. Adios.